And the goal here is that you would like to understand the measurement error, and we would like to understand the Gaussian distribution, the normal distribution. And we also want to take a look at this standard normal distribution to analyze the data, okay? All right, so this mechatronics is all about like data. You measure something, you process that data, and then you try to understand what's going on. And based on that, you want to control, like change if it's not following what you want, or just leave it as is if that's doing the good job. That's mechatronics. Is like more robotics or whatever, control, something like that. All right, and we would like to first understand the error in the measurements. All right, so this X here stands for your actual measurement, your observation of whatever quantity. And that is going to be a combination of X naught plus ER plus ES. And X naught is the true value. ER is the random error. And ES stands for the systematic error. All right. And the important thing is we think that we know the true value, but in real life, we really don't know what the true value is. True value is more like a imaginary thing, like a mathematical thing. There's no exact 2, exact 5, or anything like that in real measurement. So it's always going to be a true value that you don't know and errors that are covering this thing, and that is what you're measuring. All right, so no measurement is exact and true value is never known. And estimate, so we are estimating the true value from a distribution of observations. And let's now talk about these two terms, the random error and the systematic error. All right, so this lecture here is going to be a bunch of definitions and revisit to your statistical things that you may have learned back in high school or some other course. So random error is about precision, and like its name, it is a unpredictable fluctuation that is generally around the mean value due to any environmental noise or resolution of the your sensor, etc. All right, and the key here is it's around the mean value. It's a random fluctuation around the mean value, and that's this random error. And to avoid that, what would you do? Anybody can tell me? Say you have measured something and it has a bunch of noise, or you measured once, it's 5, you measure one more time, it's 4.9, next time it's 4.7, next time it's 5.2, something like that. What would you do to avoid any random error? Or to find the true value, estimate the true value out of it. Yeah, exactly. That's the easiest way. Take more data and average over a large number of observations. All right, and this is kind of the typical distribution of random error. So horizontal axis is the measurement value, whatever height, weight, or whatever measurement, okay? And the vertical axis is the frequency of each, measurement values. And if it were a random error, then it's going to be distributed around the true value like that. All right, and we still don't know it's a true value. We just kind of hope or estimate it's going to be around the true value, right? So, any questions so far? It's super straightforward, right? Okay. And there is something also called systematic error, and this is related to bias. And just like this bias term says, it's generally biased, or it has a time varying trend that is due to imperfect calibration or imperfect observations. All right. Say one example maybe this horizontal axis is time, and say you're measuring, I don't know, temperature or voltage or something like that, and it is supposed to be like a certain value, but it's like fluctuating, and it's going up like that maybe. Then this is coming from a systematic error, or it's a biased thing, right? Okay. Random error would have been more like this. It's more kind of centered around a true value that you guess. It's going to be like that, okay? And to avoid this, of course, because it's coming from calibration issue, you just calibrate it, have a better calibration, okay? And this kind of distribution might be more like a real life or typical thing. So again, horizontal axis is the measurement values, and vertical is the frequency of each observations. And because you cannot avoid those random error, so it's going to have like a distribution like this, and it might be slightly have an offset from the true value that we actually don't know. So there's a slight offset, and it has a distribution. This is like a combination of both random and systematic errors like that, right? And this chart, this here might also give you an idea what random error and systematic errors are. So for example, if you have an accurate and precise measurement, all your measurement is going to be centered around the bullseye like that. Okay. However, if it's accurate yet not precise, then it's going to be like this. Okay. So this precise or not precise is related to the random error, right? So this is more like, and of course, this is going to be systematic error. And if you have a precise measurement, yet it was inaccurate, then you may have something like this. And if it's not precise, neither accurate, then it's a whole mess. Like that. Got that? Make sense? So now more like a real example here. So I have measured my weight. It's not over time. It's not like today I measure, tomorrow, day after tomorrow. It's not like that. I just after shower, I just stepped on to my lousy scale and then hop down, again, measure, back, measure just 10 times in a row, all right? And this is the value that my scale gave me, okay? So this would be the raw data. And one thing that I want to point you is, if you are, after you finish this graduate and then you find an engineering job or whatever job you get, don't ever present your data like this to your boss or your friend or your colleague. If you start working, probably you're going to do some dirty work like nobody wants to do, like measure like thousands of things and then something like that. Generally, measurement is one of the things that you probably do, because from there you kind of learn whatever system they have and etc. But if you measure a bunch of things and then you just dump that to your boss, then he or she's going to be mad. Like, so what? I see that you measured a lot. So are you angry or? Okay. So you will want to process this so that your boss or colleague or teammate can kind of just get the juice out of it and then appreciate your hard work. Okay. So if you provide this to your colleague or boss and then tell, hey, if you want to take a look at the raw data, I can definitely show you that too. Then it's going to be a good kind of way to communicate because it's easier to see, oh, it's a bunch of things are here and it's are in this range and they kind of look symmetric. So that's good. An even better way would be drawing something visual like that. And you are drawing the histogram of this out of here. And this is even easier to just at a glance, you can understand, oh, it looks like that, your data, oh, it was good or bad. Very easily you can tell. So if you have something like this, you can definitely provide and that's gonna make you look good. And one thing that many times students miss is please provide your axis label. Because you drew it, you know what that is, but if someone else just taking a look, you don't know what that is, right? So please make sure that you put your axis label there. That way you don't make any miscommunication.